Hello, the name of my research topic is Enhancing Kubernetes Scheduler by Assimilating Hammersley Sequence Sampling Technique in Ant Colony Optimization. Let us understand the motivation behind choosing this research area. In today's cloud infrastructure, containers are replacing virtual machines. And to manage these containers at enterprise scale, container orchestration tools like Docker Swarm, Apache Mesos, and Kubernetes are being used. Kubernetes is the most widely used container orchestration tool in enterprise cloud, because it's an open source framework that can be easily modified according to the enterprise cloud requirements. And this is one of the main reasons that we have chosen Kubernetes framework for our research project. Let's understand what container orchestration tool exactly means. The major functionalities of any container orchestration tools include scheduling, cluster management, service discovery, provisioning, monitoring, configuration management, and auto-scaling. This research work focuses on improving the scheduler in a container orchestration tool. Let us understand what does scheduling exactly means with the help of Kubernetes architecture. So as we can see, Kubernetes follows a master-slave architecture. The master node contains components those are responsible for managing the entities on the worker nodes. The scheduler component in the master node is responsible for scheduling in the Kubernetes cluster. So whenever an application is to be deployed on any node, the scheduler contains a scheduling policy which decides on which node this application would be deployed. Going further, let's discuss about the literature review. A considerable amount of research has been carried out to improve the scheduling for VMs in cloud. You can see various algorithms like reverse auction, Markov process, genetic were used to optimize cost, execution time, reliability, availability, resource usage, and performance. Continuing with the literature review, the research work conducted for containers is less compared to that of virtual machines. Let us briefly discuss about this highly impactful research work for scheduling in containers along with our proposed work. In the first paper, we can see the objective was to reduce the network latency between containers using neighborhood division in microservice algorithm. The factor of optimization was performance. The limitations were related to throughput and scaling. In the next paper, the objective was to reduce the energy consumption rate and the cost associated with downloading the container images from the container repository. The algorithm used was linear programming. The factor of optimization was container creation. The limitations were related to container placements and resource allocation. The next paper, the objective was to improve the resource allocation by defining service level agreement classes. The optimization factor was container allocation. The limitations were that some of the service level agreement classes those were defined were vague and contradictory. In the next paper, the objective was to improve the container scheduling using ant colony optimization algorithm for Docker Swarm, and the factor of optimization was container scheduling. The limitations were related to non-uniform resources scheduling. Our proposed work is related to improve the container scheduling using efficient ant colony optimization algorithm for Kubernetes, and the factor of optimizations would be performance and resource usage. Coming to our research question, we have seen that how scheduling impacts the computational performance of overall system. In Kubernetes Scheduler, the scheduling policy which has been defined selects the current optimal node without considering the monetary cost associated with the resources. So this brings up a research question: can the performance efficiency of Kubernetes Scheduler be optimized using efficient and colony optimization algorithm? Moving further, this is a proposed architecture for scheduling in Kubernetes cluster. So, as we have mentioned earlier, the scheduler contains a default scheduling policy which selects the current optimal node for deploying any application. We would be replacing this default policy of scheduler using efficient and colony optimization algorithm. So, whenever there is a request to select a node to deploy an application, the scheduler would be using the efficient and colony optimization algorithm. Now, let us see how the scheduling will work in Kubernetes using efficient and colony optimization algorithm with the help of the flowchart. First, values of all the nodes will be initialized. Also, the solution set will be initialized. Then, the ants will randomly be placed on nodes and processed. If the termination criteria is met, the processing would stop. Else, it will start updating the solution set with the values of selected nodes. The solution set will then be constructed incrementally using HSS technique. This will continue until all the ants have been processed. After completion, the construction of solution set, the values of selected nodes are stored and further these values are evaluated using objective functions, after which the nodes are ranked based on their values. The best node is selected considering the rank, and finally the solution set is updated. Now, let us look at the system requirements to implement our proposed model. So we would be using CloudSim, which is a cloud simulation platform, and the Kubernetes framework would be downloaded from GitHub. The containers would be created using Docker Community Edition, and the scheduling algorithm, that is the efficient ant colony optimization, would be developed using Python programming language. Now, let us see how we would be evaluating our proposed model. The performance of our proposed model would be measured with respect to utilization ratio, response time, and turnaround time, after which we would be comparing the performance results of our proposed model with the default scheduling algorithm used in Kubernetes. Thank you.